Hey, Mia has to have a birthday present. It's so stupid cancer.
No, because I sat there last time, and when I sat there, I had to look through Brandon, like 18 heads to like find the board, and it's just so much easier.
I'm a pretty cool thing to look at.
Yes, this part right here. We tie it up like
If you're not here by the end of the vlog, it's all your fault, because I'm not sure how to go.
Oh, right. The mask was fine. It wasn't breaking. Yeah, a kid did this when the teacher was out of the mic and just literally cut the seat in the oh yeah. So when you see people in all you see plastic. Bro.
What? You're so tired. You want to leave? Me too. All right. We're not doing that. Who's here? Who's not here? You guys have
What? No, you didn't. No, Jessica. You're not one of those people. You're not. She thought Alaska was an island. Oh, you.
It never.
Oh my God.
It has a line that's like completely straight. How would that be an island? I don't know. I got question geography.
I've never seen
You
this.
should. That's the
Is Mia here?
No.
Is Annika here?
Yeah.
Right.
Okay. Are the twins here? No?
Not
They're not gonna be here. Oh, that's right. All right. Brandon's not here. You guys are all here. All right.
Wow, that's I'm so excited.
So, we're gonna do a number talk today. Happy Valentine's Day. I didn't bring you candy.
Yeah, happy single
Like Valentine's Day. Happy Singles Day. All right, we ready for guesses? Let's write in red today. That's good. How many? Hold on. Order your topic down. All right, Zach. What's that?
30.
Oh.
16. Well, you know,
all right. Oh, violent. Still. 28. Oh, that's seriously. All right.
25.
All right.
27.
They're really bad. All right. There.
I said 40.
All right. Anyone else?
Over.
I did 11.
All right, anyone else?
I'll just be like,
I'll do. 15.
Do you go by this? Because your email is not that.
You know,
What's your name?
Isabel.
I know that.
Okay.
That's what you write on things. What do you guys call her?
Eliza.
Okay. Why is your email Izzy then?
Because that was my nickname in middle school.
Oh.
And then I don't know how to.
I got nervous that I was calling you the wrong thing all year.
No.
Because one of my Algebra 1 students told me that I've been pronouncing her name wrong all year. And I was like, girl, you should have just told me to shut up.
Well, her name is there.
Yeah, also you're.
How would you pronounce that? Yeah, I've been saying Ronea because that's what she told me at the beginning of the year. And I feel like a terrible person. It's Renee. Right. Any other guesses?
Shall we reveal? Is there a video? Video reveal. Priya, hello. Do you want to guess before we video reveal?
Oh, yeah.
Sweetheart?
Okay, oh my gosh. 30.
3?
Oh, wait, 50.
Oh, no, I thought you said 3. 30?
We're literally just talking to the other day.
Stay with 30.
30? Alright. I don't know the answer, so. Me too.
But also they're never full for sure. That's what I'm saying. Oh, you ate two though. Oh, no.
Oh, wow. He's opening the box and everything.
Oh, yeah.
Does that piece count?
Why did he count it? Oh my god.
Oh, he's color sorting them. Yes.
Who counts it like that?
Better question. Will there be an even distribution?
There's not even amount. Wow.
Does that piece count? Nope, apparently not.
34.
The way
I know.
you count it, I was like, you would do that.
A solid quick guess.
How many is it? 35?
34. What is this?
How many numbers are up there?
I don't know what this is.
Really 35.
Oh, right. So, hello. Hi. Is anyone ready? No. All right. Hello. Hi. Question to you guys. Did we finish the notes last time? All right, we didn't finish them. Let's go ahead, and I kind of just want to do one of these questions. What's up?
Do you mind if I have a copy?
Oh, yeah, absolutely.
So grab out those 7.4 notes from last time. 7.5 is super short, so we'll take a second to finish these up real quick. So you're looking for the ones that say shell method on them? Also, this one.
Is she complaining about my teaching or no?
Copy down.
We have like 90 orders left. So I was just telling my students. You don't have to mix it up this year.
I like the white dress with the white.
Honestly, I wish everyone would wear white because it's hot as heck and the white is.
I was saying.
There are some boys that have ordered white, so. All right, so as we finish up, I kind of want to do this one question in particular. Yes, we're not on a shortened block, are we? Because it's the lunch block. Heck yeah. So I wanted to do this specific question. So you're going to notice the question we are starting with is this guy right here. we're going to do it both ways. So I'm going to review kind of disc and washer, and I'm going to review shell method, because this is a good example of a question that can be done with washer method, and it's not super difficult, but at the same time, it's kind of annoying. And the reason that it is kind of annoying is because of the difference between what's happening in the bottom half of this shape and what's happening in the top half of this shape. Does anyone notice something different about the bottom half of this shape and the top half of this kind of object as we rotate? All right, there's a hole in the top, but not in the bottom. So what that means for us, if we're going to set this up with like hardcore calculus, is that we would have to split this into two different integrals. We'd have to split it into one on the bottom and one on the top. Now, if you're clever, the one on the bottom is a cylinder, so you could use geometry to find that. But I'm going to split it into two integrals. Now, challenge question. Let's see if you've been paying attention. If I am doing washer method or disc method, so I'm rotating and creating that kind of disc shape or disc with a hole in the center, what letter am I going to have to use in my integral? So if I'm doing disc and washer, will I have to use x as my variable of integration, or will I have to use y as my variable of integration? Just, how do you know?
Because it's rotating around the y-axis.
That's fair. So if I'm using disc and washer, it's going to rotate around whatever axis, I have to use that letter. Also, if you think about the thing that you're rotating, to kind of make that disc, your radius would have to be that horizontal line, so you could make that circular cross section. So let's set that guy up first. So I'm going to zoom in quite a bit. Whee. So I'm going to have to split my idea right here. The bottom half of this, very boring. There's one specific radius. I'm just going to draw it. And then on the top, we've got this whole action going. So we've got a big radius and a small radius. All right, you guys want to jump all the way to the volume equation? Wow. So actually, let me label a little bit. So we're going to do the bottom part plus the top part. Here I'm adding because it's two different shapes being added together. So for the bottom integral, will I need 2 pi r squares or just 1? No. When you answer no to an either or question. My husband does that all the time. I'm like, do you want to go here or here for dinner? He's like, yeah. Help, yeah, exactly. We're just going to need 1 pi r squared. I'm pretty sure that's what that person meant. That blue radius right there, what 2 things am I subtracting from my top minus bottom for that blue line? What? 1 minus 0 is the claim. Do we like it? Reasons I also like it, that's constant. So remember how that looked like a straight up cylinder? That makes sense. Yeah. So I'm doing top minus bottom. Here's this 1 minus 0. So I'm going like a right minus left. Thoughts on what's missing? Thoughts on them? All right, are you talking this 0 to 1 or this 0 to 1? Why? Yeah, actually my question is my answer. It's the y values. So we're going 0 to 1. All right. Now we're going to add on the stuff from the top. I'm going to keep my pi factored out. Will I need 2 different r squareds or just 1? Or 2? And I'll be subtracting them because I'm subtracting out the whole in that case. All right, thoughts on the big radius there? So that bigger green line that I did. I heard 1 minus 0 being whispered with a question mark at the end. Thoughts? All right, thinking of that big radius there, I would argue that big radius is the same thing as the big radius we did down there, though, right? So I do like 1 minus 0. Austin is right, though. At some point, we're going to have to interact with this equation. I think that has to do with the smaller radius. What are your thoughts on the smaller radius here? can I just say x squared plus 1 minus 0? I need to have this in terms of y. So here we're going to solve. I'm going to subtract 1 and probably take a square root. Since I'm in the first quadrant here, I don't need to worry about the plus or minus. I will be doing the plus part. So do you guys like the square root of y minus 1 minus 0? All right. So, wow. Oh, wait. I'm missing one more thing. The bounds are going to be weird. 1 to 2. All right. We're still in terms of y. So do you guys like Connor's claim for bounds of 1 to 2? Cool. There are a lot of different ways you could do this integral. So if you're a little bit more clever, this is like the brute force way to do this question. If you're a little bit more clever, you could work with like a pi r squared h. That's the volume formula for the cylinder. You could find like the entire cylinder and just subtract the whole using calculus. You could do the bottom part as the cylinder and the top part as the integral. There's a lot of different ways you could simplify this, but it is a little bit more complicated. Let's compare to what that would look like. Yeah, like so I'm looking at the y values here since the y is my my variable of integration. So I'm going from 0 to 1 for that first one, and then from 1 to 2, that top point for the second one. You can always lay your pencil on the radius that you're working with and kind of slide up and down to see where it applies. Now, I would argue that this question would be easier to do if instead of laying that line horizontally, I could lay it down vertically. Because look, there's one consistent top function and bottom function for this entire space if I can lay my line down vertically. But I have to rotate around something that's parallel to that line. So if I'm doing it that way, I got to do shell method. Anyone remember the area formula for our shell? 2 pi RH. Cool. Thoughts on the radius? Anyone remember how we could find it? All right, take 30 seconds, look at your notes, figure out what the radius is going to be. I'm going to not listen for 30 seconds. If it helps, I'm gonna chuck a one here. All right, anyone feel comfortable about the radius? Should we go even farther back? What letter am I going to use as my variable of integration? All right. I'm going to call dibs on James for the partner test. All right. I don't need a partner. Sounds good. I was going to propose an idea. All right, so if we're working with shell method, I like Nicole's notice of if I'm working with disk and washer, and it goes with cross sections too. So anything that's kind of like an AB method, perpendicular to whatever axis is the letter you're going to use. So here we were perpendicular to the y-axis, so we got to use y for our disk and washer. Shell is exactly the opposite. Notice anytime we have our line kind of oriented up and down, as far as the line that's in the region, that's going to be in terms of x. So that's why this pink cylinder is going to be in terms of x. Now this radius is this distance right here. Does anyone remember how we could find that radius distance? Or anyone think they want to claim a radius distance here? Yeah, x minus 0. So there's a couple of ways you can think about it. One is you're going to take your variable of integration. So if you can decide x here, you're going to subtract your axis of rotation, or you can reverse that subtraction if you need to make that radius positive. Or we can think of anywhere our x distance is, we're that far away from the y-axis. So this distance is our x distance as we go. Thoughts on the height here? So this guy right here, x squared plus 1. If you want to be extra, we're going back down to the x-axis. You could put that -0. So again, you're thinking top minus bottom. If you don't know how to find anything, try to find two things to subtract. You're probably going to get somewhere in there. Thoughts on the bounds in this case? 0 to 1 is good. We can take our pencil. It's vertical, so we can go left to 0 and right to 1. So those are x equals 0 to x equals 1. Now, theoretically, if you did calculate both of these, you would get the same answer. I don't think I actually did it, and I don't have my notes with me. But if you get to like an assessment on this, you're working on your problem set, if you're really aggressive about checking your answers, you could do a lot of these both ways. Or on the test review, I will probably do a lot of them both ways so you can kind of see the difference between them. So there we go. All right, before we move on, do you guys want to try one of these on your own? All right, I'm going to let you guys try one of these. This radius is not just x, so I'll let you see if you can figure that out. To be very, very clear, the area that I want to revolve is this guy right here, this kind of triangle-y piece. And you're trying to rotate around this green dotted line. So this, I would use shell method for this one. This is kind of the shell that you're working with. So I'm going to give you a couple minutes to try to get your brain wrapped around it. This is a good one for shell method because I don't know how to get this equation in terms of y. So I have to stay in terms of x, which means I need that line to be vertical. Feel free to try with your neighbors or try by yourself. I'm not giving you 37.5 minutes. That would be a little aggressive. Let's try 3. Plus the time it takes to get this timer back. So like 4. Feel free to talk to your neighbor as you work about content, Valentine's Day. Yeah. Correct. Not really. So the cool thing about shell method is since there's kind of a hole already in your shape, the bounds will deal with that hole. So as long as you stop at the rightmost part of that triangular region, the shells will have a hole in them, so you don't have to adjust for it at all. Yeah, that's fine. All right. So the height here, the second one is the so that's your top minus bottom expectation. Absolutely. So the top minus bottom here, the radius. So we'll look at in terms of this shell, you're kind of layering the cells on top of each other. And then, so you can do it on the bottom, but the variable you're integrating with. So wherever you go,
So the X and O infinity are variables. So whichever one you choose to do. And then find that represents the distance between the axis or here, the Y axis, and whatever you put. And we use attributes as we keep going further down. So what would be talking about? So that is from this, would you have for so the Y for height. Yeah. Okay. Because find the expression of minus plot and its function. All right, I'm gonna start to walk around. Radius.
All right, you guys want to talk this out? Or do you want more time? All right, what do you want to do first? Radius? All right, let's talk radius then. I want this distance right here. Any claims? 2 minus x. I love it. All right, we're talking the axis of rotation. This one happens to be to the right. And wherever my line currently is in that region, I'm working in x, so that's currently at x. Remember, this distance right here is x, so we're taking the whole 2 minus that x. All right, thoughts on the height? All right, I like the idea of the function being involved. I don't like the idea of 2 being involved. I'm going to reverse that because my function's on the top, but I do like the addition of the 1. So we're going to do our function, x cubed plus x plus 1. And then the reason I'm subtracting 1 is I don't want to go all the way down to the x-axis. I want to go down to this horizontal line, y equals 1. So you should be doing function minus function there. Which one's farther up?
So like farther up from like for this.
So literally just like farther up.
Oh.
So top, bottom. You can always take an x value that's in your region and plug it in as well. And if you get a positive number, you've probably subtracted the right way. All right, speaking of in our region, we're working in x. So what x values does our region kind of go between? What are our bounds? 0 and 1. You're looking at this pink region here. Remember, through all of our investigation, these bounds have been wildly region specific. So you're looking at that pinkish triangle-y thing. You can go left to x equals 0 and right to x equals 1. All right, that's about as complicated as you can get in these questions as far as like setting things up. A lot of the choice is going to be at the front end. So I would encourage you, if you're wanting to do well on this assessment, make sure you're practicing the front end decision making. So like, which method are you going to use? What variable do I need to use? A lot of those decisions are the hard ones. All right, if you wanted to practice some more, there's a couple more questions down here, but I think we've talked this out. Did you want to try any more before we move on? No? All right, then let's try our last section in Unit 7. Arc length. This one's super boring.
What? Where did I put my notes?
All right, so we're not going to rotate anything today. We're going to find the length of something that is
So, think of this as like, a lot of calculus is like an extension of something you've done before. This essentially is an extension of the distance formula. Not in like a creepy way, but that's kind of what we're doing. So instead of just finding the distance along a straight line, we can find the distance along a curvy shape. It's going to be a formula that you end up memorizing, but I want to show you where it comes from because it comes from a place that makes a whole lot of sense. The formula is not nice though, so it creates integrals that are also not nice. So you're gonna have to do essentially none of these by hand. We're gonna do one of them, just because I like torturing you a little bit. Are you ready? No. Is the answer. What? Don't lie to me. Is there drama going down because it's Valentine's Day? Is that what's happening? I'm just gonna start drawing stuff. All right, let's say I graph a curve. And I zoom in really, really far. Yeah, I know, right? Because I got nothing better to do. I graph a curve and I'm just sitting on Desmos. I'm just clicking plus, just zooming in. Eventually, if I zoom in enough, what's that going to look like? A straight line. So we're going to kind of take advantage of that and use a little bit of Pythagorean theorem. In this space, I'm going to prove to you what the formula is. If you don't want to write this down, you definitely don't have to. I wouldn't ask you to do this. But the formula looks a little weird, and I think you deserve to know where it comes from. There's some good math inside of it. But if you just want to watch and follow along that way, totally fine. I just gave you space, mostly for me to write, but just in case you also want to write. Yes, ma'am.
Can we please have Sashi to the main office for dismissal?
Sure.
Thank you.
We're just going to work on our problem sets. Ooh. Thanks. I'm just recklessly rolling around here. Oh, seriously, recklessly. What have I done? Better, thank you. That would have been dangerous. Is it bothering anyone? I'm just like fully sitting today. Do other teachers fully sit down?
Sit down.
This chair does make fun noises if you.
It's like ready to go. Like all the other days I sat there. That's how you get the classic attention.
A little aggressive. All right. You want to be even more angry? Guess what letter they use for arc length? You'll never guess. S.
What?
I don't know why. Yeah, I don't. All right, sure. I don't know if there's really a reason. So I'm going to pretend that we're zoomed in really, really far. So instead of labeling this side S, I'm going to label it a really, really small type of S, a really small change in S. I'm going to label it DS. Like dx is a really small change in, oh yeah, in x. So I'm going to label this dx and this dy. Those d's being like the differential. So we're really, really zoomed in. We're really, 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 really tiny. So I'm going to use the Pythagorean theorem in a second, and I'm going to try to solve for actual s, which is the arc length. So we're going to end up taking an integral to get rid of the d part of the ds. As I go through this, Mason. Yeah, I think y's, x's. Again, you'll never have to do this. I just want you to know where it's coming from. So I'm gonna do essentially a proof of the formula in a second, slightly rigorously. I just want you to make sure I'm not breaking any rules, okay? So, would you agree with me and Pythagoras that dx squared plus dy squared is dx squared? All right, I'm gonna do that slightly backwards, but this is just the Pythagorean theorem. Again, if you don't want to write this down, no worries. That's fair. All right. I eventually would like to find s, so I'm going to square root both sides. And I'm going to write dy a little bit different. Now, technically, what I'm writing down is going to be by the definition of what dy is, but it's going to algebraically look like it makes sense because of fractions. But one of the things I'm going to write down technically isn't a fraction. So let's see if we can reason this out. I'm going to write dy dx times dx. Does that look like it's true? Yeah, it looks like the dx's cancel, right? And I get the dy squared, so it looks like this is happening. Technically, that's not happening because dy dx technically isn't a fraction. This is technically by definition what dy is, but is legal. Looks legal, feels legal, is true. All right. We good still?
Yeah.
All right. This guy's going to stay the same. I'm going to square each of those things individually. But I want to write, what's a different way to write dy dx? Everything's starting to look kind of complicated. Okay, fair. I asked a vague question and wanted a different answer, so let me be more specific. Let's pretend our function was, instead of named y, it was named f of x. What could I call dy dx then? F prime of x. That's usually in the formula that I'm going to write down, so I'm just replacing one derivative notation with the other. All right, now I would like an idea from you guys. This is starting to look really weird and really big. I feel like I don't know, when things look big and weird, I feel like I might be able to factor something out. Do the two things inside the square root have anything in common? Yeah, a dx squared. So they have a dx squared here, a dx squared here. I'm going to factor that out. So I'm going to have ds is, let's see, I'll have dx squared at the back. I know the second term, I'm left with this f prime of x squared. What's left in the first term? If I factor dx squared out of dx squared. Oh, fun. No, but kind of looks similar. I would agree. Similar vibes. There's a lot happening in the room next door. You guys hear the desk? All right, now, how many times, despite your guys' attempts to make this work on the test that we just took, how many times have we seen one of these differentials actually like squared? Theoretically, we really don't see those differentials squared, right? But that dx squared, he's under a square root, right? Could I do this? So this has to stay because I can't square root things individually. But if they're multiplied, I could do that, right? So I'm taking this guy right here and I'm saying the square root of dx squared is dx. Legal? All right. Yeah, there is a lot happening. What does it look like we could do now? If I want to get from ds to regular s. Integral. So here's our formula. Just like a whole conversation going on at that table. Nothing to do with my class right now. So there's the formula that we're going to be using. Now, the cool part about this formula is, one, it's going to make an integral that's usually too complicated for us to integrate by hand. Two, I could actually do this process almost exactly the same way, but kind of what Michael was going at. I could flip that derivative upside down, so I could do dx dy instead with the first term. So doing this in terms of y is actually just as easy as doing it in terms of x, and we'll see both of those options. Really, at the end of the day, you're just going to want to memorize that guy. We'll look at a similar one at the very end of the year for something called parametric functions, when we have an equation for x and an equation for y. That'll actually make memorizing both of them a little bit easier because they look very similar. So we're only going to do one of these by hand today, and then we're going to do the rest of them with the aid of a calculator or just a setup that do not evaluate. Really, if you're going to choose to focus on any of the questions we do today, you're going to want to focus on the last two. They have to do with kind of AP questions. So we're going to try two of those together, but I want to just get our feet wet first. So let's do this first question. We'll take a short break after it because I'm going to actually make us integrate this by hand. I like doing this question first because it lets us check and see if the actual process of what we're doing is working. Meaning that we already actually know how to find the arc length of this question. What's another way to say like the distance we travel around a circle? Circumference. So I can, it would be like half the circumference here. So what's the formula for circumference? 2 pi r. So if I want half the circle, I could divide both sides by 2. What is the r of this circle right here? 1. So I should get pi times 1. I know out of this answer, I should be getting pi. So we're going to check through our process and use this formula by hand one singular time to see if it works. So I'm claiming this distance around should be pi. Let's see if we can get that using calculus. Are you ready? No? Why not? All right. All right, a lot of this is just formula, so I'm just writing the formula stuff down that's not going to change. The square root's always going to be there. The 1 plus whatever squared is always going to be there. The big job we have is to put whatever we have as our derivative in those set of parentheses. I see a problem. Yeah, I see an equation to take a derivative of. Anyone remember how to write the equation of a circle? Say it louder. Perfect. Where's the 1 coming from? Radius squared. Perfect. I would like to do this guy in terms of x, just because I think it's easier. So I'm going to solve this for y. And I'm going to get this lovely square root of 1 minus x squared, which is not the same as 1 minus x. Please stop doing that. All right. With your neighbors, find me y prime. I'm going to eat a Starburst while you do that. I'm sure you guys have eaten a piece of candy today. Really?
I have not.
Ew, that one's watermelon. Ah. Yeah, you should be. I have the derivative of square root memorized, so if you have like 1/2 and the negative 1/2, I just have it memorized. It's like the simplified version. Do you chain negative 2x? Cool. All right. So, correct me if I'm wrong. I'm not, but whatever. This is what I'm getting for my derivative. So, good identification of chain rule. Highly recommend if your brain has any space for memorizing the derivative of square root is super helpful because we do it so often. If you don't, you have the 1/2 and the square root I have on the bottom is from the negative 1/2 power that shows up when we subtract 1. Negative 2x on the right-hand side is coming from that chain rule of the negative x squared. And then I just chose to cancel the 2. You've been taking derivatives for a long time now. So. What's missing? Bounds. Thoughts on them? Negative 1 to 1. If I had done this in terms of y, would the bounds still be negative 1 to 1?
Oh, no.
Yeah, it'd be 0 to 1 because I'd be going down to 0 up to 1. All right, just for fun, we're going to try to do this integral by hand. Thoughts on first steps? It's not plug in the bounds, so I'm going to just rewrite them. What would you do first if you were trying to do this by hand? What would you simplify? You're optimistic. Sorry, that sounded way more sassy than I meant to do. What I mean by that is there's nothing kind of outside the square root. So that would be optimistic to hope that the derivative of the inside was a constant. I'm going to go ahead and do that squared. Is that cool? All right, so I'm going to leave 1. And I'm going to square the top to get x squared. I'm going to square the bottom to get rid of that square root. Anyone else bothered by the fact that this is like 2 different fractions, or it's like a 1 plus a fraction? And you kind of wish it was just like 1 thing instead of 2 things. Could I make a common denominator? If I want, yeah, I would love to. Yeah, so this front one, I'm kind of just gonna make it like this over this, right? So let's see. Hold, please. I'm gonna keep this square root because I'm scared I'm gonna get rid of it. So I've got 1 minus x squared as my common denom. So that 1 will now be 1 minus x squared over 1 minus x squared. And plus an x squared. Ooh, y'all. Yes. Do you guys see what Jill's saying? That you could cancel the x squareds in the top? All right, and the square root of 1 is 1, right? So let's like square root the top. And then on the bottom, I can't square root that, but oh y'all, this looks so familiar. Ooh, I like the idea of arc. Is it tangent or sine? Arc sine. What's U? U is our x. What's A? 1. So I don't have any u sub. I don't need to worry about anything. It's literally arc sine x from negative 1 to 1. All right, let's see who knows this thing. All right, I'm about to ask you 2 equivalent questions. What is arc sine of 1? Equivalent question, where is sine 1? At what angle? Yeah. So pi over 2. All right. At what angle is sine negative 1? What? No, I just didn't hear. I have old ears. Let's go 3 pi over 2, I think, at the bottom, right? Because 3 pi over 4, you're still at square. The pi over 4s are all at square root of 2 over 2. Okay, cool. We actually can't use that 3 pi over 2. We have to use the kind of equivalent angle if we rotated the other way. So we're going to use a negative pi over 2. It's in the same place. We just have to use that because of the restrictions on sine. But looking at this, what's pi over 2 minus negative pi over 2? It's right. It works. Wow. Now, would I ever find the circumference of half a circle this way? No, that would be silly. But I do know my formula works. So when we come back from our break, we're going to try this on 2 different questions where it is curvy and we would have to use this. We will evaluate on a calculator. So if you don't have one, I would grab one. And then we're going to finish our notes today with talking about how the AP test is going to ask you, because I actually really love those questions. And there's one that's almost directly like it on your problem set. Our notes are pretty short today, so let's take 5. Have a calculator at the end of these 5 minutes. What is? Oh wait, you guys are actually like indoors today, right? How exciting!
Yes.
You could be outside today. It's very cold.
It's good for like the straight, but the curves are so tight. You gotta like.
Does it?
drag your feet
Does
across.
it?
It's not that good.
So it's small. Yeah, I've seen the Navy jacket.
This one, the smaller size, but it'll make.
Ooh, that must make it awkward to run.
It's terrible, like the worst.
It basically means that you have an advantage because you're snapshotting or running a not too good at that.
I've never PR'd in this track unless it's a straightaway. It's impossible. No one does.
It's impossible.
And then also for like our long jump marks, for some reason last time we looked at, all of our long jump marks are like 4 feet under what they actually showed it.
Weird. What are your guys' thoughts on starting like a college board where everyone writes down where they're going to college?
Yeah. I don't know.
I don't know yet either.
No, like not right now.
Oh,
Just whenever you find out, you get to write it up on the board. We used to do, one of the teachers used to do it a long time ago, and I don't think anyone's taken the plunge to be the person. Need to get some new markers. Yeah, does anyone know yet where they're going? There? What? Nice. I figured. Good school. Everyone thinks I hate that school because I went to UVA. I'm like, but it's a good school. You know what I do hate though? The Hokie Stone. Can't stand it. There's like a specific stone from a specific like quarry that they use to make all the buildings at Tech. My tour guide was really into it. And I was not. I was just really angry that day. There was a girl in the like intro session. They were telling us if you had like 2 years of a foreign language in high school, you didn't have to take any more foreign language. And she raised her hand. She's like, what if I have 3 years? And he's like, then you're a superstar. I was like, I can't go to school. Michael's the only one that knows. Oh, really? I'm excited. It's an exciting time of year.
Don't you have to do all the like planning and stuff and that stuff?
Planning for what?
Graduation.
Oh, yeah.
Yeah.
Oh, it's only my 2nd year doing it, so it doesn't suck yet.
Last year was your first?
Hmm?
Oh, wow.
So this year feels like a first all over again because it's like
Yeah, 'cause-
nothing we did last year, minus the actual day of graduation will be the same. Although last year's graduation went really well.
Was it still the same style really?
Yeah.
Graduation's still gonna be a fun one, right?
Yeah, and this year we don't have to worry about the cicadas.
All right.
Nice.
Yeah, the parents fought so hard to have graduation on the front lawn last year, and we were like, "You're gonna regret this." Decatur Central. Luckily, they kind of.
Oh, I forgot about.
I kind of miss them.
A little bit.
They were kind of fun.
It's a nice noise about it.
They're so loud in my house.
Although one at the senior picnic last year, one flew and landed on my face.
My brother's friend made a dead one last year.
Oh. Did that happen at landscaping? I feel like that's probably what happened.
And then you just see how like the cicadas that are like their bodies flying around. How are you so loud?
Very resilient bugs. Y'all, I'm so excited to start Unit 8. It's my favorite. So much fun.
What's your least favorite unit?
To teach or like to do the math?
I guess both.
To teach, probably 10.
Is that Taylor series?
No. Taylor series I like. That one's challenging. 10 is polar, parametric, and vector. Parametric and vector are super easy. Polar's just weird. And it has a lot to do with the unit circle.
Oh no.
So none of you will probably like it that much. But it's fun. It's the end of the year. It's just weird because we go from like, here's how to plot a point, because polar's different. You get a radius and an angle, to like, let's integrate between two curves in the span of like 3 days. So,
What's
All
the
right.
last unit we get to do before you leave?
what?
What's the last unit?
That one. Yeah, we only have, so we're finishing 7. We have 8 left.
When are we expected to finish?
We'll probably finish. We probably won't test unit 10, but we'll finish by spring break. I promise I'll teach you everything. All right, so let's find the arc length a couple of times and then talk about how this is going to get asked about on the AP test. So here, finding the arc length, really all the calculus that's involved once you've memorized this formula is just finding a derivative. Since this one is given in terms of y equals stuff with x's in it, I'm just going to go ahead and do this in terms of x, so that I don't have to worry about converting anything to y's. So I'm going to say arc length, which is going to be our s. I'm going to set this up with the square root and the 1 plus. Really, this is going to be mostly a fight with your calculator to make sure you remember all of those little pieces before you plug it into the calculator. Let's talk about taking the derivative of this function, though. I would highly recommend not using a ton of quotient rule, and by that I mean not using any quotient rule at all. What would be a better way to write x cubed over 6 so it doesn't look like quotient rule? Does that make sense as a question? I don't want to do like a low d high minus high load with x cubed over 6. Yeah, so I could rewrite this as 1/6 x cubed. Thank you for reading my mind, Mia. Can anyone think of a way to write 1 over 2x not as like a fraction? All right, I like the idea of 1/2, and I heard someone talking about negatives. What could I do with a negative? Negative exponent, I'll go with -1. Since I'm going to be plugging this into the calculator, I don't really have to worry about simplifying my derivative. I could if I want to. So like this could be 3/6x squared once I take the derivative, or just 1/2 x squared. And then I'm running out of room. Sorry, I'm only erasing that because I'm running out of room. Bring down the -1, so minus 1/2 x to the -2 all squared dx. Honestly, on tests where I've given a question about arc length, I would say 99% of the people set it up correctly, and the errors come from actually just plugging it into the calculator. Before we plug it into the calculator, I am missing one thing. Bounds, can I just use the interval? Yeah, they're x values, so I'm going from left 1/2 to right 2. So I want everyone to try to plug this into the calculator. Don't forget your square root. Don't forget your squared. Those are the 2 major mistakes. You're also going to want to make sure you're preserving the parentheses I have around my derivative. Let's all try to plug it in and see if we get the same number. Can you remind me how to get an integral? Math 9. Is that only half an hour left? Time flies when you're having fun. Yeah. I just took the derivative of our function. So 3/6x squared, simplified the 3/6, brought down the -1, subtracted. Powers the little arrow above divide.
I hate my life. Oh my god.
Did you forget the square root?
Parentheses, but I erased my entire screen and I have to do the whole thing over again.
That's the unfortunate part of these calculators versus Desmos. Or if you forget the square root, there's like really nothing you can do. You just have to retype the whole thing. Yeah.
As you say that, like I just, okay.
Take your time.
All right, this is the number you should be getting. If you're not getting it and you are confused, I can help. If you're getting a syntax error ever, that's probably because you used the subtraction button instead of the negative button. That's one of my biggest qualms with this calculator is it has two different buttons, one for negative and one for subtract. Yeah, they should be the same button. They are not. Are we cool? All right.
No, like, projected like.
Oh, I can hear you. You don't mumble like some other people in the back.
How did someone mumble more than I?
I don't know. Ask Austin. He's being real sassy to him today. He's not paying attention much, is he? I can't tell. Unless his head is blocking. Hi. All right. So, cool. Interesting. Awesome. Yep. That's a good question. So if we were working with units, they would be some sort of distance units. So you could do like meters, miles, whatever. If I don't give you units, though, you don't have to find them. All right, let's flip to the back, and we're going to do probably only 2 of these questions. I just want to show you that this is exactly as easy to do if you're working in terms of y. So this one I could pretty easily set up in terms of x or in terms of y. And our function is not solved for one of these versus the other. So I'm going to solve this to get an x equals stuff with y's in it by taking a square root. I could write that as a root, but I'm going to write it as an exponent just to make my life a little bit simpler. So thinking of square root like to the half power. That's going to help with the derivative as well. So I'm finding essentially x prime. I'll bring down the 3 halves. Subtract 1. And my chain rule is just a 1 in here because the derivative of y with respect to y is just 1. So I've got my derivative to plug in. Still 1. Still taking my derivative. This time essentially dx dy and squaring it. Thoughts on bounds? That would be great if we were working in terms of x. 1 and 5. All right, so this seems pretty straightforward and not very interesting. And I'm pretty sure the AP test people thought the same thing. So they came up with a really clever way to ask about this question. Not really, actually. It's just a little bit more thinky, and it's not that much more thinky. So, yeah. So the way they have us working through this is actually talking about perimeter. And I think these questions are really cool because they have you interacting with arc length in a very straightforward way, but they also have you interacting with more parts of the question. So I'm going to try one of these, and then I'm going to have you guys try one as a way to finish unit 7. So here is our function, g of x equals e to the 2x. We want g to be the region in the first quadrant bounded by this graph of g, the coordinate axes, and x equals k, where we don't know where k is, we just know that it's greater than 0. So if we're talking about this region, we've got this kind of curvy piece on the top. We've got this piece right here, this piece right here, and this piece right here. We are going to write an expression, meaning we're just going to write it. We don't have to evaluate it. That gives the perimeter of G in terms of K. So this idea of perimeter is a way for me to do arc length without them just saying, hey, find the arc length. Because if I think about the perimeter, I want to take this little man and I want to walk him around the entire thing. That's going to include the arc length of this guy. Now, I could set up the arc length of the other 3 pieces, but I would argue those 3 pieces we can evaluate without having to do this giant formula. So let's talk this out. I hate when I erase the parts. I don't want to erase. All right. Let's start with this piece right here, that vertical piece. It's a vertical line, so I don't think I need calculus to tell me how long it is. How long is that vertical line? 1, because it goes from the x-axis up to y equals 1. All right, let's try this piece right here. How long is that piece? K. It's going from 0 over to K. All right, slightly more challenging. Still don't need calculus, but slightly more challenging. How long is that line? Good. What Sydney is doing is she's taking the k that was our x value and plugging it into that curvy function. So she's getting e to the 2k. Now, this last piece, that's curvy. So this piece is going to be some arc length. So my perimeter, I'm going to take 1 plus the k plus the e to the 2k, and then I'm going to add on an actual integral. All right, I need my square root, I need my 1 plus, and I need a derivative squared. I'm just going to go in terms of x because my function is currently in terms of x. What is my derivative of g of x? What is g prime of x? What is the derivative of e to the 2x? E to the 2x, and where is Jess getting her times 2? Not product rule. Chain rule. That's the derivative of our 2x at the top. The last thing I would need is some bounds. I was in terms of x, so what should my bounds be? 0 to k. Okay? It just says write an expression. So here I would technically be done, all good to go. So that was an actual AP test question over the last couple of years. There was probably 2 or 3 points for this question. 1 to 2 are probably based off that integral. The final answer is going to have you doing that 1 plus k plus e to the 2k. All right, so to finish up our time doing notes today, I want to give you guys a solid couple of minutes. This one's slightly harder, just because it's a little bit more interesting. I was going to say interestinger. It's not a word. It is now. All right, so I want you to find this perimeter. I would again encourage you to think of it as a bunch of different pieces. So you have this piece, this piece, this piece, and this piece. I would say one of them has to be done with arc length. 2 of them could possibly be done with arc length, depending on how you're thinking about it. I'm going to give you 5 to think, and then we're going to go over it. Again, this one says set up and evaluate on your calculator. If you're feeling lazy, you could just do a setup but do not evaluate. It looks like it would be annoying to set up on your calculator. I am actually most interested to see how you deal with this one. Yes, I'm serious right now. What, the toilet? Loud toilet.
Still not one time. Like a door. No. Oh, yeah. Sometimes, I swear it was like a purple pen. Oh, yeah. I didn't hit it. Why did you from the bathroom? No, the bathroom. What's this? Oh, like something. Or oh, it looks like a burger. No.
Oh no. Oh no. Alright, anything that's not in the integral should not have x's in it. Yeah.
Also, this is not free.
I was like, I guess I maybe have one. Oh, no, that's
That's where we're at.
You just got eating candy.
They painted the roof white outside, so it tends to look brighter than.
Why?
I'm not really sure.
Well, keep the temperature of the building down.
I guess.
It's like, this is not helpful.
Yeah. Also, my windows are like broken. All right. Since we're not making a whole ton of progress by ourselves, let's make some progress together. So I'm gonna label these lines so it's a little bit easier to talk about them. I'm gonna label them A, B, C, and D. Does anyone have anything to tell me about any of those lines?
I can give you C.
All right, what's C?
I have it as C.
You have it as E. Does anyone else agree with E? How do we get that?
I plugged in 1, so that's an F value.
Mm-hmm. Perfect. So we're doing 1 times E to the 1 squared. That is all E. So keep in mind, don't assume anything from the graph. Don't assume it's 3 because it looks close to 3. You have to use the functions being involved. All right. So I know E, part of my answer. Anyone have any other claims about any of them? Cora. All right. The square root of 5 is A. This one we could have done the arc length formula for. How did you get the square root of 5? Yeah, there's this lovely triangle in here. Man, that toilet. I could do 1 squared plus 2 squared is A squared. So A is the square root of 5. Cool. All right. I've kind of given away what B is. Does anyone know what B is? 2. Now I want to be careful. If you did plug 1 into that function, you're probably going to get -2. I do want to count these as positive distances. So do make sure you kind of absolute value your stuff below the x-axis. All right, letter D, I don't think we can just make up. We're probably going to have to do some actual calculus for that, but I'm going to set up the first part. So let's do the square root of 5 plus 2 plus E. You can do any of those in any order you want. It really doesn't matter. And this last curvy part, this is our calculus. Anyone have anything to tell me about the derivative part? That's a great question. Which one am I taking the derivative of? Which function controls this piece of the graph? The black part. Sorry, I didn't. Yep. So I could, this square root of 5, I could set up an arc length formula for using the -2x part. But this guy I need for my curvy one. Any thoughts on my y prime? What am I going to have to do for x times e to the x squared? It's product and chain rule. So we're going to do first derivative of the second, e to the x squared times 2x from the derivative of x squared plus second e to the x squared, derivative of the first is 1. So I'm just going to simplify this as I roll through, mostly just combining those x's in the first term. And a dx at the end. And this seems to be the theme with a lot of these perimeter questions. They've been putting a lot of them on lately, where they kind of have a bunch of numbers and then one of the pieces is arc length. Am I done with this question? Yeah, I need bounds. I keep forgetting them today. Any thoughts on the bounds for this arc length question? 0 to 1. We're talking from the left to the right. I wonder if that toilet, has anyone listened to any of these? Can you hear the toilet on the recording? Yeah, that's fair. Someone screamed earlier today because they found a book that they had lost and they were excited. All right, so that's the end of Unit 7. Huzzah! We have about 10 minutes left of class, which is not as much as I wanted. So in the next couple of classes, I would like to build in some time to work on that problem set, but I would also encourage you to not only work now, but also work a little bit at home if you can. Let's talk dates. The dates on the front don't really matter, but I'd like to do a proposal for how I would like to treat the Unit 7 test. I've been pondering it in my head, and we haven't done a partner test in a while. No. I'm gonna say when you make unrealistic proposals, then I just want to do a normal test. So, all right. So I would like to propose that the problem set be due on Friday. You have had it for like 2 weeks. Well, because the problem set is due, or just because? All right, so I'm gonna set up time to work on it next class, but I would like to propose this Friday problem set due. I would like to not propose that the test be on Friday, even though that's kind of 2 classes from now. I would like to propose the test be on Tuesday, 2/22. I would like to propose that this be a partner assessment. Partners by Hefty. Meaning I will choose your partner. And I would like to propose an interesting form of mastery. Have we done a mastery test in here before?
Yeah.
Where I walk around and check it off?
Yeah.
I would like to do that, but slightly differently, where I'm not walking around. I would like to make a Desmos form where if you type in the number, it tells you if you're correct or not. Okay? Yeah, so if you were in my class last year with the notes checks, essentially if you plug in the right number, it'll say correct. So what I'm imagining, and I'll kind of make a trial of this if I can show you for next time, is there will be like a Desmos screen, and let's say there's 10 questions. There'll be a blank for each one, and you'll essentially just fill in the number that you would get for the problem. There may be some questions where it's not going to be kind of a number format, and I'll figure out those differently. But for most of these, if I say find the volume, you're going to set up an integral and you're going to plug it into your calculator. You would put in that number. Let's say it was that one we just did, 2.0625, and it would, if you're correct, it'll be like correct. What that'll allow me to do is it'll allow me to walk around a little bit more and answer some questions, but it'll also allow you to get feedback on if you are getting the right answers. Do you accept my proposal for the test?
I feel like that is an amazing proposal for the test.
Perfect. I like doing like at least one partner test this quarter. This quarter tends to be a sad quarter just in general. It's hard. It's a hard quarter to be alive. Also, just FYI, we're gonna start Unit 8 next class. Unit 8 is a long one. There are at minimum 6 sections. And it is all very new and very different from what you're used to.
Oh, boy.
Can I get your attention for approximately like 1 more minute instead of just packing up? I have 6 more minutes of your time. So Unit 8, it's long and it's very different. So I would love to have a quiz about halfway through. We haven't taken a quiz in a long time, but just keep in mind that there will probably be a quiz on a quiz about halfway through Unit 8, maybe halfway plus, and then a test. That test again will kind of come up as we go. So those are your upcoming assessments. I think since this one is mastery, as long as everything goes well on this test, ideally there will not be a round 2, because since you're able to check your answers theoretically, you should be done during that class period. If things go awry, we can adjust as necessary. All right, so bring your problem set next time. We'll start Unit 8, but I'm going to condense those as much as possible. If you are not notation friendly, sorry. Unit 8 is essentially as close as we get to proofs. I'm so excited. It's my favorite. All right, that's it. Do whatever you want. Goodbye. Hello.
Bye.